Hi everyone, welcome to my YouTube channel. So with this video, I am starting a new series which I'm calling as Building Data Science Projects in Industry and MLOps, which is basically machine learning operations. So far, based on my limited experience of building some solutions across multiple industry verticals, I am planning basically to cover some of the important aspects of building a real life data science project through this entire series. Now, most of the time I have seen lots of courses out there, but for a beginner who has no experience in industry, they find it quite challenging to understand how a data science project looks like inside the industry. So here I will try to share some of the interesting stories which will cover most of the real world processes by which a data science project is governed and developed. All right. So this is an introduction video of the series, and let's try to understand how a typical data science project looks like in the industry. So as you can see here in the diagram, a data science project, it is full of multiple components. Now, most of the beginners, they initially believe that building a model is the all data science project that is basically there. But if you will see here, so machine learning code, it is a very small part of the entire data science lifecycle. There are a lot of parts which are data collection, data verification, feature engineering, model analysis, and lots of other parts are there in a data science project. So this diagram basically shows the actual complexity of a real world data science project. Like in industry, you will have to look at all these components in a proper way, and only then your data science project will be able to make in the real world. Otherwise, there are lots of projects that basically fails in between. So like almost every other project, data science project also starts from the ideation phase. So let's try to understand what is ideation phase. So in this phase, the interest is basically to find out what will be the problem statement. So sometime what happens is that whoever are your stakeholders, they will come with some very specific requirement. And that is when we can say that the problem statement is very well defined. Now, if I will talk about an example, then an example could be that let's say our stakeholder is a telecommunication company, and they want to build a noise removal system to improve the call quality. Now, here we know that we need to build a noise removal system, right? So here a project may start directly from a POC, and if the outcomes will be as per the expectations, then next step could be to think of extending it for an MVP, which is basically a minimum viable product. Now, sometimes these problem statements could be very ill defined. Now, when I say ill defined, so let's say there is another stakeholder, and they are basically interested in increasing their revenue. So in this case, there are lots of possible information that we will need to think for a potential solution, right? Because revenue could depend upon lots of things. And an ideal way would be to basically first understand about the company, their internal processes, their business model, right? So such project needs to get started from discovery proposal rather than a POC or MVP. Now, what is discovery? It is basically a process where the data science team needs to come up with some questions to gather more details about the problem and to proceed in a right direction. So discovery proposal, basically it is a nothing but a presentation deck which is generally prepared along with the timeline for the discovery and key outcomes. Now the timeline may be around 1 to 2 weeks or even more depending upon like how complex is your problem. Okay, so once both the parties, data science team and key stakeholders agrees to the discovery proposal, then both the team, that is data science team, and key stakeholders, which may consist of let's say business people and technical persons or even sometime end users. So these two teams basically they sit together and they discuss about the existing processes, and they kind of jot down the various answers. Now these conversations could go on multiple back and forth, right? So based on multiple sit togethers and sync ups, finally the backlog is prepared and RFPs are done. So this discovery is mostly needed only for the ill-defined or a very complex problem. Otherwise, for a straightforward problem like the noise removal system that we have discussed above, the discovery is mostly not needed, right? And directly we can start working, creating backlogs and RFPs. Now, I have mentioned the backlogs and RFPs lots of time, right? So you might be thinking like, what is this backlog? What is RFP? Okay, so let's understand what a backlog is. So backlog is basically a simple sheet or document where we basically write down the key components to be built as a part of the solution. And what are these key components? So these key components could be like, let's say for the noise removal system. So it could be, let's say, initial research. Then after that, you will be doing the data acquisition. Then you will be doing the data preparation. So these could be the components. And there is a very standard word that is being used across the industry, and it is called as epics. Now, I mentioned these as the components and epics, but usually the best practice is to kind of name your epics in such a way that it should be understandable to the even the non-technical persons, some business persons who are there, right? Okay, so now once we will have the epics, so let's say you were able to extract 5 epics for your noise removal problem. Now for each of the epics, some one-liner stories are basically created to further drill down and define the part of work that is done for each of these epics or these components. Now, when I say one-liner stories, so what happens is that, so let's say initially the first epic would be the research work. Now, inside research work, basically you will have to come up with 2 or 3 or whatever you feel, some one-liner stories where you will say that what actually is the research that you are planning to do in that particular epic. And that way you will also able to get one another information which is very important for a project, which is the timeline. So if you will say that I will initially research on what could be the potential data set that we should use for our problem, then you can just put some timeline there with that one-liner story that you are adding inside the research epic. That, okay, I will take around 2 days or 4 days or 5 days related to like whatever is the complexity of that one-liner story, right? So that is basically called as the story, and we basically add it inside all the epics. Now let's talk about the RFPs. So RFPs are again nothing but a document, I would say, which basically summarize the entire thing, like your problem statement, then whatever the possible solution that you are trying to propose, then the timeline that you were able to compute after you have prepared your backlog, epics and stories, then the assumptions that you are making for that timeline, and it could be budget, then it could be high level team structure, then one of the also good practices to basically come up with initially some naive solution. If it is a cloud based, so it should be cloud native solution. If it is an on-premise solution that you are planning to propose, then it should be some just a simple flow that will basically showcase that these are the steps that we will do to achieve the final solution. So these are the basically some key things which are basically part of the RFPs, which is called as a request for proposal. All right. So once the RFPs are created, then it is basically presented or pitched to the customer or stakeholder, whoever he is. And based on the various consideration like pros, cons, finally the deal is kind of made. So either to start a work or not. So basically it's a win or loss of the deal. If it's a win, then finally a statement of work document that is prepared along with some terms and conditions on which both party agrees. All right, so that was all the details about the ideation phase, and I hope you will be now comfortable talking about these points to someone. All right, cool. So let's move on to the next phase. So the next phase is a research phase. So the research phase is where the data science teams start to actually validate the pitched solution. Now, there may be cases where the solution that you have proposed or pitched earlier that may not work, or you were able to find some better solution, and that is completely fine. So because that always and most of the time happens, like during the proposal you proposed some different solution, and later in the research phase you found out some other potential solution that you feel is a better one than the earlier one, and that is completely fine. Actually, the key here is basically to look for any research or even a related one which basically relates your problem statement. Now, most of the time the problem could be exactly the same one that you are solving, and you can comfortably try to build the newer one based on that one. Now, during this phase, we can also find out if machine learning is a way to go, or other non-ML way will also work fine. Because if the problem, let's say, can be solved using some simple digital image processing technique, right, then it will be an overkill, right, if you will use some heavy ML based solution, because it was easily solvable using some DIP techniques. So all right, now based on the research and exploration, there may be some potential data set which you think that they could be usable, but based on my experience, it's very rare that you will get some data set which can be directly plugged into your problem, and you will have your solution. It's very rare. So during the exploration part, we should list down the data sets that we may be able to modify accordingly based on our use cases, with some additional pre-processing. If I want to talk about an example, so let's say that we are working on some problem statement of removing noise from the audio data. Now, for this problem, we can easily build our data set by our own, right? By modifying the data which are available as open source and for commercial purpose. You can collect such audio data, and similarly, you can collect the noise data, and you can prepare the data in a very supervised way. Like what you can do is you can mix the noise data with the cleaned audio, and that will be your input audio, and then you can try to predict the actual cleaned audio, that will be your output, right? So that way you can build the data set of your noise removal problem. Now, one of the very important point is to kind of always cross check the usability license of the data set which you are trying to use, because if it's a free for commercial purpose, then you can use it. Otherwise you should not use it, right? Because if it is not for commercial purpose, then there is no meaning to use it. And this is a very important part. Now, apart from the dataset exploration, another research work is also done for the right solution. So here various state of the art methods and techniques are kind of explored and compared with the existing processes to decide on how feasible it will be, considering the various constraints which may be there, like real-time inference, then low latency, then deployment cost should be low, and there could be various other constraints out there. All right, so based on the exploration and research work, it is a very good practice always to come up with a flow diagram as well, so that it can guide your team during the implementation phase. And also it's a good practice to design a cloud native solution if possible, because that can also guide your MLOps or infra team basically to plan the initial deployment. All right, so that was all that is basically done in research phase. Now let's move on to the next phase. So next phase is data acquisition phase, and it is comparatively the most tedious phase, I believe, compared to the other phases. So here data store like AWS S3 can be built initially to collect all the potential data set discovered in research phase. Now, sometimes what happens, right data set may not be available at all. So in such cases, it becomes quite tedious to plan for the generation of required data set, because the generated data set, it must reflect your real world data, right? That for the problem that you are solving. Otherwise, your model will fail miserably. So one of the most widely used solution is basically to build a simulation system to generate the data and kickstart your model journey. All right, so that was all I wanted to add here. Now let's move on to the next phase, which is data exploration and data preparation phase. So this is, I would say, also a very important step of the entire journey, because there are, even if any minor mistakes done in this phase, then the entire model building and validation that goes in vain. Because even though you will get a good validation scores, your model has a very high chance of failure when deployed in real life, right? So here we should list out the various specifications about dataset structure. Like if it's an ASR system and we are going to work on audio data, then we should know the existing system's audio data very well, like in terms of audio format, then in terms of sampling rate, then audio chunk duration, and any other necessary parameter. So, and this should be very done with a very proper validation from the stakeholder side as well, right? So that you can prevent some future failures that might happen. All right, so that completes our data exploration and preparation phase. Now let's move on to the next phase, which is about model building phase. And this is, I believe, to be the most interesting work for most of the folks, right? All right. So to build a right solution, whether an ML1 or non-ML1, the best practice is always to research and explore the similar work areas so that you can get a very good understanding about the various solution possibilities. I always recommend everyone to look on paperswithcode.com, as I feel it's the best informative site, which basically collates all the active research specifics in a very nice and informative way. And one can easily look up for the various state of the art approaches and validate it with the various constraints for a proper viable and feasible solution. Now when I say constraints, then it could be a thing like whether batch solution will make sense or real-time solution. Then other could be that if it's going to be a real-time solution, then what is the latency that would suffice, right? So these could be the constraints that we can have from the stakeholder side. So based on above, one can start building and experimenting in that direction. All right, so that completes the modeling part. Now let's talk about the next phase. So the next phase is about the model validation. So model validation is not about validating it only on out of the fold data set created from synthetic or open source means. It should be done in a proper way on an actual data set where the model will be deployed. In most of the cases, I have seen that the data science teams only validate their model on the synthetic data, which is collected from various sources, and later that model fails silently in production. And that may lead to lots of questions and dissatisfactions as well, right, from the stakeholder side. So the validation data should reflect the actual production data, but I feel it's always a best practice to test the model on actual production data set and prepare a report of results to get a good direction. Like if you want to proceed for further model enhancement, then how you should go about it. All right, so that was the validation phase. Now the next phase is the deployment phase. So this is where the core machine learning operation works starts majorly. So initially the solution that was developed is hosted over a web server like AWS EC2, and a very simple API interface using Flask or some other way is created so that the quality analysis team, they can interact with your actual model and they can validate whatever the core functional requirements are. And parallelly also the scalable solution based on the production constraints are being developed. Now building a scalable solution is again a very tedious process, because for any problem there is never a best solution. Every solution they will have always some pros and cons, and it can never be a single shot. Like with just one iteration you will be able to kind of design a very intact and perfect solution. So it basically requires lots of iterations to finalize the most productive and a feasible solution, in terms of scale, in terms of latency, then cost, simplicity, and various other parameters. So basically the key is kind of to build and implement a basic solution initially, and then with the load testing and all later figure out like what the bottlenecks are, and then you can plan to kind of how to mitigate it. Now, most of the time I have seen that decoupling the components that basically fix up most of the bottlenecks, but not always. Okay, so now after various end-to-end load testing, once the architecture works as per the production constraints, then finally the IAC, which is basically called as infrastructure as a code. So that is implemented by DevOps or your MLOps team to fully automate the deployment. Okay, so that was all that I wanted to cover in the deployment phase. Now let's talk about the last phase, which is called as monitoring phase. All right. So in this phase, various KPIs, then metrics, then logging structures are basically created so that you should be able to monitor the performance of your model. And not just the performance of your model, but the performance of business and as well as other indicators that you might be interested in or your stakeholders might be interested in. Now, it becomes very important to track the model performance on production data, as even a minor mistake or a drift that can lead to a very significant impact on business. So to account for these kind of critical changes, most of the time a proper alert system that are kind of built so to notify the person who is responsible for the resolution. All right, so that was the last phase of the data science project lifecycle. So to summarize, so far we have learned about how a data science project start in industry and how it is built. Awesome. So we have completed part 1 of this series, and I hope you were able to learn something useful here. So thanks for watching, and let's meet in the next video.